Hello everyone, this is Lab 4. We're looking at a mass spring oscillation. The purpose of Lab 4 was to examine the motion of a mass on a vertical spring as the body oscillates in the x and y directions. Introduction of the key terms for this are the GlowScript computational model, the periods of spring oscillation, spring force equation, the velocity and position update formula, energy principles and their equations, and the preview of this is that things will oscillate on a spring pendulum system. Introduction of the key principles is the period of oscillation is going to be used to get K. The spring force is used to get stretch. Energy formula is used to get the mechanical energy, and then we will use the velocity update with Newton's second law as well. These are the relevant formula to know for this lab. Reasoning. The GlowScript was used to compare the predicted results to the actual results. We use the prior principles talked about over here for this process. The energy graphs are used to determine if energy is leaving the system, and if the objects are in simple harmonic motion, then the spring constant can be solved for. And then the tracker model was used to get the x and y points for each time period from our actual experiment. The systems and surroundings. The system for this was that the mass in the ball, the spring, and the earth. The surroundings were the air, which caused drag and a loss of energy due to work from friction. And the initial conditions were there was no starting velocity, there was a stretch in the spring, the mass of the ball was 0.402 kilograms, and the spring length was 0.7 meters. The experiment itself was we put the mass on a spring, attached it vertically to the ceiling. We then pulled the mass to the side, only horizontally, not in the z direction, making sure to stretch the spring to a different L than the resting L when the mass was attached. Then we let it go and recorded the per frame position of this ball to determine the x and y oscillation. From this, we made a model to predict the path of the mass. In doing this, we used this code. This is the section before the iteration loop. This is the section after the iteration loop. You can see we needed to know the spring constant and then the resting length. We also had to use gravity, and then we found our L, L hat, and our S from this. You can see that we just plugged in our values for kinetic energy. This is the mass due to gravity, the potential energy due to gravity, the potential energy due to the spring, and this is the total energy, which is just adding up all of these. Then, from this, we had our initial, for all of these values, which was just set to what we found here. Then, using all of these, we updated those values, and then set them back to the new values, so that they would become the initial values again. That way we can measure the change in these each time. Here is the results. So this was our change in energy graph. You can see that the orange line being the change in energy, that there is no change, where the green is the energy, the potential energy of the spring, the red is the potential energy of the gravity, and then the blue is the change. This is our x position oscillation and our y position oscillation, the red being the actual experiment, and then the blue being the computational model experiment. From these, we can see that the peaks and troughs are consistently inconsistent. By that, we mean that they happen at the same interval, it's just that those intervals are shifted. We can see that the period is similar for the x and y direction. These two look about to be the same period. The total energy is consistent, as stated earlier, and the differences is that the amplitude is off. These do not look the same. Additionally, they are shifted some. This could be from the errors on misclicking on the tracker video, or the calibration could be off. For the what-if questions, first question being that because the total energy of the system never changes, the energy principle is satisfied. When the potential energy of the spring decreases, the gravitational potential energy increases. In this way, they cancel out. In the model, no work is being done. However, in the real life, there is work done due to things such as friction. And then the x direction of the period of oscillation was found to be 1.64, and the y period of oscillation was also 1.64. This is because the spring constant and the mass are the same for either direction. Therefore, in the equation, t equals 2 times pi times the square root of m divided by k, the answer would be the same for both x and y directions. Thank you for your time.